Hi, my name is Beth, and I have a question. Why don't we talk about the hole in the ozone layer anymore? 20 years ago, when I was growing up, I learned about the hole in the ozone layer. I don't remember a lot of details, but I do remember three things. The ozone layer is an important layer in our atmosphere. Human behaviours and products were causing a hole in it, and something about a chemical in aerosol spray cans being problematic. Now, I don't use many aerosol products, but every now and then I remember the ozone layer issue and it makes me think. So I wanted to do some research and figure out why we don't hear about the hole anymore. Before I get into the current status of the ozone layer, I think it's important to cover some background material for reference. Ozone is a gas with molecules made up of 3 oxygen atoms, found in a layer in the atmosphere. It's created when high-energy ultraviolet radiation in sunlight hits oxygen molecules, O2, made of 2 atoms, and the energy splits the oxygen atoms apart into 2 free atoms. Those free atoms aren't stable on their own, so they combine with another oxygen molecule, O2, to make an ozone molecule, O3. There is so much oxygen in our atmosphere that this reaction happens constantly. As UV rays are reaching our atmosphere, ozone and oxygen molecules are being broken up and then reformed, and since these reactions are using up the energy of the UV rays, the ozone layer is absorbing a significant portion of the UV radiation reaching Earth from the sun. And this is all happening way above Earth's surface in the stratosphere. There are 3 types of UV light, A, B, and C. The ozone layer blocks all of the UVC radiation, about 90% of the UVB radiation, and half of the UVA radiation, which is incredibly helpful, because, for example, UVB radiation has been studied and found to be particularly effective at damaging DNA, causing cancer, as well as causing sunburn and eye damage. So while we still have to be careful and aware down here on Earth's surface about our exposure to UV rays from the sun, without the ozone layer, we'd have a lot more to worry about. For instance, we'd get sunburn after only 5 minutes outside, and we'd have a lot more skin cancer. So the ozone layer is incredibly important. Now, what's the deal with the hole? First of all, it's important to acknowledge that while we call it the ozone hole, it's technically not a hole, but instead an area with a significantly thinner ozone layer, which was initially identified over the Antarctic in the 1970s and 80s. One of the main perpetrators responsible for this hole is a group of chemicals called chlorofluorocarbons, which are made up of chlorine, fluorine, and carbon, and are called CFCs for short. These chemicals were developed in the mid-1900s to use in refrigeration, because before then the chemicals used in fridges and air conditioning systems were toxic, which isn't exactly ideal. By the 1970s, CFCs were widely used because they're stable and the molecules stay intact for years. And this is where my memory of aerosol spray cans being involved comes in. CFCs weren't just used to keep our fridges and AC systems cool, they were also used as a propellant in spray cans, helping to get the products out. So CFCs were being widely used because they were a huge improvement over the toxic chemicals that they replaced. They were stable compounds and didn't break down or react with other chemicals. At least not in the lower atmosphere where we are. Since they're so stable, they can continue floating around in the atmosphere for a long time, and some of them can make their way as far up as the stratosphere. When they get there, they're no longer protected from high-energy UV rays by the ozone layer, and that energy can break the bond that holds the chlorine to the CFC molecule. That chlorine atom is now free to wreak havoc on some ozone. When a chlorine atom meets an ozone molecule, it steals an oxygen atom, creating a chlorine monoxide atom and an oxygen molecule. But that's not the end of the cycle. It continues. When a chlorine monoxide atom meets a free oxygen atom, it breaks up, and the oxygen atoms combine to form another oxygen molecule. leaving the chlorine atom free to go and break up more ozone. And this can happen over and over and over again. In fact, one chlorine atom could go through this cycle over 100,000 times. Looking at that information, it sounds like we should be expecting the ozone hole to cover the whole planet, but that's not the case. The ozone hole is generally seen over Antarctica in the early spring, which in the southern hemisphere is September to October. And that's because it's not just CFCs that are involved in destroying ozone. Chlorine from other molecules gets involved as well. In most atmospheric conditions, the two chemicals that store the most atmospheric chlorine, hydrochloric acid and chlorine nitrate, are stable. But the long, dark Antarctic winter isn't normal atmospheric conditions. Antarctica is very isolated from the rest of the world by a huge ocean, and the wind patterns around the globe, including polar easterlies, create vortexes around the poles. The air above Antarctica is dark in the winter, getting no sunlight to warm it, and it gets so incredibly cold that clouds form even in thin, dry air. Unusual chemical reactions happen, and chlorine that was previously being stored in stable chemicals is now found in more active forms, like chlorine gas, made up of just 2 chlorine atoms. When the Antarctic spring begins, the UV light from the sun breaks the bond in the chlorine gas, leaving free chlorine atoms in the atmosphere available to be part of the reactions we talked about previously that destroy ozone molecules. These reactions keep happening until the atmosphere above Antarctica gets a bit warmer, and the winds around the continent get weaker, so the air gets more mixed and chlorine isn't concentrated and held in the region. Then the cycle happens again next year. This is obviously not great. The ozone layer is incredibly important in shielding the Earth from UV rays, and if it's being destroyed by chlorine and humans using CFCs, then we have a problem. And this is where we get an incredible example of international collaboration to work on a global environmental issue. On September 16th, 1987, the Montreal Protocol on Substances that Deplete the Ozone Layer was adopted, and it came into full effect on January 1st, 1989. Nations that signed on to the Montreal Protocol were agreeing to phase out the production, use, and import of ozone-depleting substances, including CFCs. And the list of chemicals controlled by this list has grown over the years, as research has suggested additional restrictions. The most recent amendment was just 5 years ago, and it initiated the phase-down of hydrofluorocarbons, HFCs for short, which don't actually deplete the ozone layer, but became commonly used as replacements for ozone-deleting substances. Since HFCs are greenhouse gases, they contribute to climate change, so they're being phased down anyway. The Montreal Protocol is regarded as an incredibly successful effort to reverse negative human impacts on our environment, but it hasn't been all sunshine and rainbows since 1989. The compounds in the atmosphere that created this issue are stable and long-lived, and they're still out there, so the road to recovery is slow. 15 years after the phase-out of ozone-depleting substances began, the largest ozone hole on record was recorded in 2005, with an area of over 10 million square miles. But there's hope for the future. In 2008, the Montreal Protocol and the Vienna Convention that was part of its creation became the first international environmental treaties that achieved universal ratification, meaning they were signed by every country, which is incredible. And a study in 2014 showed that the ozone layer is healing and will return to its pre-1980s self probably within the next 50 years. And not only that, the UN estimates that the results of the Montreal Protocol will result in an estimated $1.8 trillion in global health benefits and almost $460 billion in avoided damages to agriculture, fisheries, and materials between its conception in 1987 and the year 2060. So in answer to my original question, the reason we don't hear about the hole in the ozone layer anymore is that it's recovering. And since ozone-depleting substances have been phased out, other compounds are used as aerosol propellants, so our spray cans aren't hurting the ozone layer. This is an incredible success that was achieved through international cooperation and willingness to act, and I hope it's something we see more of as we continue tackling the next big global environmental challenge: climate change. If you'd like to learn more about the chemistry of the ozone layer, the history of the ozone hole, or the Montreal Protocol, then check out links below to the NASA, British Antarctic Survey, US Environmental Protection Agency, and UN Environment Programme websites where I did my research. There's a lot of incredible information out there. Thank you so much for watching, and if you have any questions you wonder about, then let me know in the comments below, and I may look into them for a future video. Like, comment, subscribe to see what questions I ask and answer in the future, and I'll see you next time.